Good morning, everyone. My name is Jonathan Stojkovic. I'm API evangelist at MuleSoft, and today we're going to talk about how to build consistently great APIs using API specs. So before I begin, just a quick note that you should base your purchasing decisions on products and services that are currently available. So that's our standard slide. And now, let's move on to the agenda. So we're going to talk about why APIs. We're going to go over why do APIs matter, and then we're going to talk about why API specs and what you can do with them, and we're going to go over practical examples to illustrate that. So why API specs? Really, why? Writing software is like building with blocks. But as an application grows, those blocks become increasingly complex and it's messy. So it becomes important to refactor those blocks so they can be reused across a single application and even multiple applications. And so that your applications become more concise and maintainable and look more like this. And when you think about it, this is not a new concept. CDs are built on top of shared infrastructures, and they wouldn't scale otherwise. So this is practically the same thing. So why do APIs matter? Going back to our blocks analogy, APIs are just that. They're things that connect blocks of code to one another. And there are different kinds of APIs. APIs can be exposed as command line programs, as libraries, as classes, or even over the network, which is what we call HTTP or web APIs. But to summarize, APIs are a way to expose functionalities that can be leveraged across one or multiple applications. So now, why API specs? The concept of specs is not new. It dates back to the 90s. We call those model or schema languages, but they're essentially specs, and they still exist today. But in the beginning of years 2010s, web or HTTP or REST APIs, depending on how you call them, gained in popularity, and so did API specs. So from there, we started seeing two layers, the API layer and the data layer, and they can be combined. So how does it work? Let's see. So sometimes you need to share data types across several APIs. And here on your left here, there's a system API exposing user data. And on the far right, there's what we call an experience API, which exposes account-related information. And using that for practical reasons, but also to ensure consistency. So here we have a user, a type shared between both APIs, and also ID, which is not only shared between those two APIs, but also reused in the user type as well. So here, this is an example of a search API that exposes different ways to search data. But more importantly, this API spec describes how the response of that /search resource returns a polymorphic response composed of 3 different types. This is an example of a people API that returns employees, but those employees are also users. And so the API spec presented here allows me to reuse that user schema and merge it with the employee schema to define a response composed of both. I'll give you a few seconds to read it. Here again, I have a people API that now exposes users by ID. That user schema showcases 2 ways to provide examples. One is at the property level, and those examples will be inherited. And the other one is at the object level. And those examples, wherever I use them and provide a better, so the goal of this is to provide a better developer experience, as those developers will be able to see by reading the API spec what those schemas exposed in headers, requests, and responses should look like. So in this example, I'm defining a pattern or template, if you like. There are a few things interesting about that. For start, the schema for those get and post request and response is passed a parameter called object type, which allows me to reuse the same resource type for two different resources. The other thing that is interesting is the use of the resource path name parameter, which allows me to templatize the text descriptions of my resources. This example shows how I can externalize and reuse patterns, in this case, order and pagination. And again, I'm using parameters. If it's good, yeah. To pass custom variables, such as the maximum number of items I can return in a single page, or the name of the fields I can use to order my results. Another thing I can do with API specs is design secure APIs. So here, I'm designing an API that handles both OAuth 1 and OAuth 2 security schemes. And I give you a little bit more time to digest it, because I know it's So one other common scenario is designing APIs that behave differently based on their environment. So going back to security, in this case, I can design my API and then apply an extension over my API spec to either disable security, so I'm disabling security in this case, for the development environment, or add another security scheme such as here OAuth 1 for legacy API that I want to expose. So I'm overlaying my API spec that's on the left with either one of those extensions with different security schemes depending on my environment. So that's dev in the middle and legacy on the right. So in this last scenario, I wanted to showcase the importance of API specs by showing you how to build APIs that can scale. So the first thing to notice is how I've used libraries to modularize as much as possible. And you'll notice that I have two sets of libraries, but I can have as many as I want. So to the left, there is an API that I've purposely limited for my free tier. I'm passing custom parameters, and I'm rate limiting that API. And to the right, there's a premium tier that exposes everything that my free tier has, while increasing limits and adding a new resource called /organizations. So can anyone tell me what happens if I don't use API specs? Do you know the answer? It's a question that's meant not to be answered. So, so here we go. This is what happens. You start seeing error message like, please, and that's bad, obviously. So, but more seriously, what happens if I don't use API specs? So first of all, it's more work to design APIs because it leads to more boilerplate code. It's more work to maintain APIs, and it's to inconsistency between my APIs. No API contract means it's harder to test. No API contract means APIs are more prone to errors. And no API contract means that it can lead to security issues as well. So the bottom line is that it's harder to manage APIs without API specs. So today, specs are everywhere. So there's event information in async API and cloud events. There's deployment information in Kubernetes. There's system information in Docker files. And those formats, when you think about it, they all have different structures, but they share metadata. So let's take a closer look at what it looks like. So let's imagine we have an API to deploy, which is behind a proxy. All layers of my infrastructure have metadata in common, so why not share that metadata? So let's see how this could work. So here I have 3 files. I have RAML to define my API. I have Kubernetes to define my pod and deployment information. And then I have a Docker file, which describes one of my container. When I say they all share metadata, as I'm illustrating here, you can see the open ports on both the RAML file and the Kubernetes file are repeated. The HTTP endpoint and methods are also in both your RAML file and your Docker file. And your authentication is also both in your RAML file and your Kubernetes file because you'll need it for deployment. So to sum up, I can use port numbers to enforce security policies to dynamically manage firewall config. I can use HTTP methods and endpoints to dynamically route proxies to API backends, to setting caching rules as well. I can use authentication to enforce security policies across my infrastructure. So we only covered the surface of this today, and I know I didn't provide any answer on how to share metadata using tools, but if you're interested in the matter, I invite you to take a look at the AML project, which is an open source project maintained by MuleSoft, and it has documentation and practical examples and a tool called AMF that show you how to parse several files and then understand common semantics and even use the single source of truth concept to take, for instance, your API definition and then propagate the metadata in there in your application infrastructure and reuse that in Kubernetes and Docker files as well. And of course, there's RAML, which is the RESTful API modeling language that we use at MuleSoft, which is compatible with OpenAPI. You may have heard of OpenAPI. And so RAML is the difference between RAML and OpenAPI is that RAML has a kind of a more concise syntax, and it has features that allows you to reuse pieces of your API specs. But both formats are compatible today. So if you use RAML in the MuleSoft Anypoint platform, you can automatically generate all of your API specs in OpenAPI. So, questions? I'm guessing there are questions. Yeah? Microphone? Oh yeah, there's a microphone here. Sorry. So if you have questions, please. Yeah. No questions? Okay. Thank you.